You've been running your car's AC all wrong, and that's why it's not blowing ice-cold air. In the next few minutes, I'll show you simple, expert-approved hacks that can make your car's AC blow twice as cold, saving you from sweating through every summer drive. Proper refrigerant recharge, why exact amount matters. The performance of your car's AC system heavily depends on the correct refrigerant level. Refrigerant is the cooling agent that absorbs heat from inside your vehicle and releases it outside. If the refrigerant charge is too low, the AC won't produce sufficiently cold air, causing discomfort during drives. Conversely, overcharging refrigerant can lead to excess pressure, which damages the compressor or other components. Maintaining the precise amount of refrigerant allows the system to operate at optimal efficiency, ensuring colder, more consistent airflow. Technicians use special gauges to measure and refill the refrigerant to the manufacturer's recommended quantity. This process not only improves cooling, but also helps prevent leaks and preserves system longevity. Regularly checking and properly charging refrigerant compensates for natural loss over time due to leaks or wear in seals. Neglecting this can cause the system to work harder, increase fuel consumption, and eventually result in costly repairs. Using recirculation mode for faster and colder cooling. Recirculation mode is a feature that reroutes the air inside the vehicle back into the AC system instead of pulling in hot outside air. This allows the AC to cool the already cooler air from inside the cabin rather than constantly trying to cool the warmer external air. Using this mode can drastically improve the speed and effectiveness of cooling. When the AC system blows cooler air faster, the cabin temperature drops quickly, enhancing comfort during hot weather. Additionally, recirculation mode reduces the workload on the compressor, which helps in maintaining energy efficiency and extends the overall life of the system. It's particularly useful in stop-and-go traffic or dense urban areas where outside air can be hot and polluted. However, it's important not to use it constantly without fresh air circulation, as this may increase humidity and fog the windows. Pointing AC vents upward for better air circulation. The direction of your vehicle's AC vents significantly affects how cold the air feels inside the cabin. Pointing the vents upward rather than straight at occupants or floor level promotes better air distribution. This allows the cool air to circulate more efficiently throughout the entire cabin space. When air enters from the upper vents, it cools the interior air volume faster because cold air naturally sinks. This natural circulation pattern spreads the chilly air evenly, reducing hot spots and making the whole cabin more comfortable. Directly aiming vents at yourself may provide quick relief but limits overall cooling performance. Moreover, upward vent positioning prevents the AC system from overworking to compensate for uneven temperatures. It also helps reduce moisture buildup on windows, improving visibility and driving safety. Replacing clogged cabin air filters regularly. Cabin air filters play a crucial role in maintaining clean air quality inside your vehicle. Over time, these filters collect dust, pollen, and debris, becoming clogged and restricting airflow to the AC system. A clogged filter reduces the volume of cold air reaching the cabin, making the AC seem weaker. Replacing the cabin air filter regularly ensures that air flows freely through the system, allowing the AC to operate at its maximum cooling capacity. It also prevents strain on the blower motor, helping to reduce wear and potential electrical issues. Beyond boosting cooling efficiency, a clean cabin air filter is essential for health, as it removes pollutants and allergens. Failing to replace clogged filters can cause musty odors and reduce passenger comfort. Checking the filter every 12,000 to 15,000 kilometers or annually is recommended, especially in dusty or urban environments, to keep the AC blowing fresh and cold air. Increasing engine RPM to boost AC compressor efficiency. The AC compressor in your car is powered by the engine, so its efficiency correlates to engine speed or RPM. Increasing the engine RPM slightly can improve the compressor's performance, resulting in colder air output. When stationary or idling, the engine runs at low RPM, limiting compressor speed and the amount of refrigerant circulated. By gently pressing the accelerator to raise RPM, the compressor spins faster, increasing refrigerant flow and enhancing cooling power. This technique is particularly helpful during traffic stops or long idling periods when the AC tends to feel less effective. However, it's important to avoid excessive revving as it may cause unnecessary engine wear. Maintaining a moderate increase in RPM strikes a balance between boosting cooling and preserving engine health. Resetting the car's AC electronic control system. Modern vehicles utilize an electronic control system to manage the AC's performance, including temperature regulation and compressor cycling. Over time, glitches, sensor errors, or system faults can cause the AC to blow less cold or behave erratically. Resetting this control system recalibrates the electronics and can restore optimal functioning without costly repairs. The reset can be done by disconnecting the car's battery for a few minutes or using a diagnostic tool to clear error codes. This process allows the vehicle's AC module to reboot and refresh sensor data, correcting any temporary faults caused by power surges or sensor misreadings. A properly reset AC system enhances compressor operation and airflow control, often bringing noticeable improvement in cooling power. It's a simple troubleshooting step that owners can try before consulting a mechanic. Cleaning or repairing condenser coils for optimal heat exchange. The condenser is a critical part of the car's AC system where refrigerant releases heat absorbed from inside the cabin. Located near the front grille, condenser coils can accumulate dirt, bugs, or debris over time, reducing their ability to dissipate heat effectively. Cleaning condenser coils improves heat exchange efficiency by allowing air to flow freely across the coil surfaces. A dirty or damaged condenser forces the compressor to work harder, reducing cooling intensity and increasing wear. This can result in warmer air blowing inside your vehicle. If coils are bent, leaking, or corroded, timely repairs are essential. Straightening bent fins with a fin comb and sealing minor leaks can restore performance while preventing refrigerant loss. Avoiding overuse of max cold setting for system efficiency. Using the max cold or lowest temperature setting on your car's AC continuously can negatively affect system efficiency. While max cold delivers the coldest air instantly, running it non-stop forces the compressor to work intensively, consuming more energy and increasing wear. Gradually setting the temperature to a comfortable medium level after initial cooling prevents the system from overexerting. Once the cabin reaches a pleasant temperature, adjusting the controls to maintain that level promotes balanced compressor cycling and energy use. Frequent use of max cold can also lead to moisture accumulation within the system, causing potential odors and reduced air quality. Managing temperature settings smartly avoids unnecessary strain on components while still providing ample cooling, prolonging the AC's lifespan and vehicle fuel efficiency. Checking for and fixing leaks in AC hoses and seals. Leaks in the AC hoses or seals are common causes of diminished cooling performance. Refrigerant loss through tiny cracks or damaged seals stops the system from maintaining adequate pressure, resulting in warmer air from the vents. Regularly inspecting hoses for cracks, brittleness, or oily residue helps identify leaks early. Similarly, seals around fittings and connections can degrade, causing slow leaks. Fixing leaks promptly usually involves replacing worn hoses or applying sealants designed for AC systems. Addressing leaks prevents refrigerant depletion, maintaining the proper cooling cycle and system pressure balance. Timely repair also limits additional damage to related parts like the compressor. Overall, leak detection and repair are vital maintenance practices to keep your car's AC blowing strong and cold air consistently. Simple $5 hacks and tricks mechanics don't usually reveal. Mechanics often keep small, cost-effective hacks under wraps, but some $5 tricks can significantly improve your car's AC cooling performance. For instance, adding a small amount of refrigerant dye during a recharge helps detect leaks easily with a UV light, saving costly repairs later. Using a foam air filter cleaner to maintain the cabin filter or conditioner vents keeps airflow smooth and dust-free without expensive replacements. Another trick involves placing reflective sunshades on your windshield to minimize heat buildup inside the car, reducing the AC's workload. Replacing worn-out rubber gaskets around AC vents with inexpensive weather-stripping tape improves the insulation and prevents air leaks. These minor investments maximize cooling efficiency without large expenses. Incorporating these smart, budget-friendly tactics complements regular maintenance and keeps your car's AC system performing like new. Thanks for watching. Try these tricks and feel the difference in your car's AC right away. If you found this helpful, hit like, subscribe for more smart car tips, and let me know your results or questions in the comments below. Stay cool and drive safe.